Hi, this is Brian Kim. I'm going to share with you case number 163 in the best way to do cataract surgery series. This is a 3+ dense lens, but also a giant pupil. And so you'll be able to see a beautiful example and illustration of chopper placement for double chop, cross chop, and how I'm able to leverage mechanical forces to crush lens pieces into smaller pieces. By doing it this way, I am not handcuffed by having to use high vacuum and ultrasonic energy to grab pieces. I'm able to use a chopper to pull lens pieces up out of the bag. And again, sandwiching the lens pieces and leveraging mechanical forces to disassemble the lens safely and efficiently. So you can see this is the patient's left eye. There's somewhat of a Bell's reflex here. I'm able to have the patient look straight using the cotton tip to steady the eye, use a corneal marker, which will help me to center and size the rexus. Asking the patient to look to the left, holding the eye still with the cotton tip, trying to get a nice flat approach for my paracentesis incision. Do the same thing on the other side, having the patient look towards the right of the screen, getting a nice flat approach, which will create a nice corneal shelf and allow me to achieve a self-sealing incision. This is intracameral lidocaine and some epinephrine and some dispersive viscoelastic to flatten the anterior capsule and coat the corneal endothelium. And this is the triplanar corneal incision. I make a vertical groove, place the blade into the deep part of the groove. You can see I have excellent control as I make my incision, and then I enter. This is the Haldey-Perkar sharp tip forceps to go in sideways. And then I puncture the center. The tear went a little bit towards the left. Go ahead and grab the tear. Again, this is a pretty big pupil, and so that's why it's very important to use that corneal mark, which will allow you to determine the size of the rexus. Going around circumferentially, you can see excellent control with these low profile forceps. It's going nice and steady. A little bit of peripheral radialization forces, but not too bad here. We'll finish off the rexus, burp some viscoelastic out, and this is the capsular fornix hydrodissection technique. I place a cannula under the rexus edge contra-incisionally, get a gorgeous wave, decompress on the left side, sweeping under the rexus edge on the left side, hooking the peripheral lens on the right side, and the lens begins to spin. You can tell this is the left eye. This patient has a little bit of a Bell's reflex, a little bit of jiggly eye movements here. Irrigating the surface of the eye, lifting the incision with the chopper, going in with irrigation off to minimize Descemet's trauma, and then removing the surface epinuchal material. And then I'm pronating my hand, sliding the leading edge of the chopper underneath the rexus edge, getting it to the equator, tilting the phaco tip vertically subincisionally, bringing the instruments together. You can see that compression force, that whitening of the leading edge of the lens piece, placing the chopper around the right heminucleus, pulling it centrally toward the phaco tip and fracturing that lens completely in half, lifting that first quadrant up with some vacuum and then crushing it into smaller pieces. And so you're going to see this again in half speed, pronating my hand, sliding the chopper underneath the rexus edge. I know that I'm there. I rotate the chopper vertically and it pops down into the capsular fornix. I rotate the phaco tip vertically subincisionally. You can see I'm able to engage the lens on both sides. I can feel the tactile feeling of that. I've gripped the lens on both sides. I bring the instruments together, compress the lens, and it fractures completely in half. Pronating my hand and getting it underneath the right heminucleus, turning the chopper vertically once again, pulling it centrally toward the phaco tip, feeling the resistance as I'm compressing the lens between the instruments and then fracturing that right heminucleus. Lifting that first quadrant up with some vacuum, and then again crushing the lens between the instruments over and over again, and then emulsifying the lens piece. And so that's really the most important step, is knowing how to position the instruments so you get maximum crushing force. Now remember, all the traditional techniques of lens disassembly, you're going after the lens piece from the top. It makes no sense when the thickest part and hardest part is deeper. And so that's why using this technique is just so much more efficient. It's easy to do. And if you know what you're doing, you really never struggle or worry about being able to get lens pieces out. You can do it very efficiently. And again, you're utilizing less ultrasonic energy as well as less vacuum to do it this way. So again, I'm using crushing forces. I used another cross-chop maneuver to crush and bisect that second quadrant. And then I'm using crushing forces to break up that remainder of the pieces of the second quadrant. Very carefully, I'm trying to turn the lens. It doesn't really want to turn, so I'm going to try to grab it and lollipop it and lift it up a little bit. In this case, it's okay to use a little bit of vacuum and ultrasonic energy to impale that lens and then rotate it up versus trying to spin it. I can spin it. You've seen me in my other videos using other techniques to mobilize that second stuck heminucleus, but I feel good about being able to just use a little ultrasonic energy, grabbing it with some vacuum and then lifting it up out of the bag. Because you don't want to create any more torsional stress on the lens. Using some vacuum to lift that last piece up out of the bag, getting the instruments around the lens piece. Again, all of this is done right here without ultrasonic energy or vacuum. Very well controlled. As a result, I'm able to place that chopper deep in the bag and I'm able to crush the lens pieces. So that's the thing. Most people, the way we're taught is never place that phaco tip deep in the bag. Don't do that, don't do that. Well, why? And that's because most people think about the phaco tip as a machine that uses vacuum and ultrasonic energy. Well, but if you don't use ultrasonic energy or vacuum at that moment, you're not using it as that. You're using it as a chopper. That's why it's called double chop. And so you can place that phaco tip deep in the bag very confidently since you're doing it for a different purpose and you're able to fracture the lens much more efficiently. I'm removing the epinucleus here, and we're done. We take the chopper out, push PSS in, take the phaco tip out, and I go in with the INA handpiece. Start to remove the cortical material. We can see it's already rather loose, so I couldn't really start, and that subincisional area is already kind of coming out. Switch to polish mode, polishing underneath the rexus edge. And whenever it comes out like that in an uncontrolled way, I've noticed there's a lot more cortical wispy material, but that's okay. I'm using polish mode to very carefully and gently removing that material out, and then also polishing underneath the rexus edge as well of the lens epithelial cells. And so again, that's really the key, and that's why it's called double chop. The phaco tip is not acting like a phaco. It's not using ultrasonic energy or vacuum. You're using it to crush the lens. So I'm using the cannula to pulse into the subincisional capsular fornix. You can see some loose stuff coming out now. Go after it with the INA tip there. And then this is cohesive viscoelastic to fill the capsular bag. And for good measure, we'll go ahead and start sweeping. Starting subincisionally polishing and sweeping underneath the rexus edge of lens epithelial cells. And then sometimes you're able to hook cortical material in the subincisional area as well, if there is any. That's why sweeping is really advantageous and really good. You can polish for lens epithelial cells, but also get any stubborn subincisional cortical material. This is a single piece acrylic lens that's going into the capsular bag. And then quickly transitioning to the INA, activating irrigation, making sure both haptics are off the optic, going underneath the optic, tilting it and rotating it 90 degrees clockwise, making sure there's no material left in the bag. Sometimes there's some wispy cortical material that's stuck to the bag. I go back underneath it. Switch to polish mode, polishing underneath the rexus edge. Getting underneath the lens again, I saw some fine lens material, and that's why I'm going after that again. Polishing some more, and then go to visco mode, and then I'll hydrate my incisions, and that'll be the end of the case. So again, double chop is all about having two instruments to crush the lens. That's why it's called double chop, not just the chopper, but the phaco tip. So you're redefining the use of the phaco tip and not utilizing it in traditional way. And that's part of the problem. People have a mental block and they think, okay, the phaco tip is supposed to be used for vacuum and ultrasonic energy. Well, not necessarily. And you can leverage the use of just using mechanical forces, because now you can place that phaco tip deep in the bag safely and confidently, because you're not using those things. You're not using vacuum to suck and accidentally grab something, or using ultrasonic energy and accidentally break something. And so by using it as a chopper, you can position that phaco tip deep in the bag, which therefore you're not approaching the lens from the surface, which is utterly inefficient. You're able to go deep and sandwich the lens more effectively, crushing it in half. And that's why you can see how I'm able to easily and confidently fracture the lens pieces using mechanical forces, even though you might think it's how do you do that? It's impossible to be able to fracture the lens that way. Well, that's because I'm able to get underneath the lens with the chopper, and I'm able to get around the lens with the fingertip, stabbing the lens, and again, gaining leverage and traction of the lens on either side, fracturing the lens very easily and confidently, and doing that over and over again, being able to use that chopper out at the capsular fornix, being able to hook lens pieces up out of the back. And this is why I think this is the best way to do cataract surgery, especially in a 3+ dense lens with a giant pupil. So I hope this was helpful to you, and I thank you for your attention.